Hi guys, I'm live for kind of porch rant, but it's also kind of talking about physics and the universe and stuff like that. It's kind of a science lecture, but it's informal, so it's kind of like a rant. So, how you guys doing? Um, so people talk about how special life is um, on Earth. How special is life on Earth? But they leave out, and that's true. But if you take it further, actually the universe is special, the whole universe, because the universe doesn't have to be coherent like it is. If there were too much mass, it would be too chaotic. If it was not enough mass, it'd be too thin and just evaporate. It has to have exactly the right amount of mass to even be a stable universe. The four forces, electromagnetic forces, gravity, and the strong nuclear force and the weak nuclear force, have to be at the right proportions, or one would take over, and we also would not have a stable universe. If the electromagnetic force was greater than it is, there probably wouldn't be nucleus in the atom, and then therefore no matter, or at least nothing stable matter-wise. There'd be no atom, and I don't know what there'd be, just totally unstable micro subatomic particles, or if there'd just be nothing. So even the universe is special. All the facts of physics don't have to be true, but they just happen to be true. And if they weren't true, the universe wouldn't be stable, or not stable for very long. So we don't just have a Goldilocks Earth, we have a Goldilocks universe. And I like to talk about gravity, because I don't think people talk about it very much. Newton formulated theories of gravity, and Einstein had a way of looking at it. Albert Einstein had a way of looking at gravity that I think is interesting. He pictured, okay, space-time is like a stretched out cloth, let's say. And if you put a big baseball on it, it's going to come down. And because matter warps space-time. And when matter warps space-time, it creates a plunge that attracts other matter near it to join it in that space-time, which is why there's gravity, which is why gravity happens. Gravity doesn't happen simply because mass is inherently attractive. It happens because mass bends space-time, which causes wormholes that cause like little space-time black holes. Only it's not quite the same, but it's similar. You create a funnel that other particles can fall into, and the bigger they are, the faster they fall. And when you fall faster, you first of all you when you fall faster, you increase your energy. And when you increase your energy, you increase your mass, because E equals mc squared. If energy goes up, mass goes up. If I increase my energy, I'll actually get bigger. I just don't do it enough for it to be noticeable physically or to the naked eye. But as energy goes up and energy keeps going up, mass gets bigger, which makes it fall even further and faster, and energy still goes up, and then mass still goes up, and that's why bigger things fall faster to the Earth than light things. They bend space-time at a faster rate because they're bigger, and that's a vicious cycle, because as they get more energy, they actually get bigger, and then next thing you know, things can get unstable. But our solar system, for instance, our universe, I should say, is really, really well balanced to even exist like it does. And but again, about those wormholes, it's a good metaphor for people. Some people have the phrase "go down a wormhole," because that's a perfect metaphor for spiraling. Because when you go faster and get bigger, you also go faster and start going. Time goes slower for you, so things don't happen as much as fast for you, because the equations of space and time indicate that if you move through space, you move through time at a slower rate. So as you move faster into the wormhole, time slows down for you, and you can't get out because you can't move. But you're going faster, which gives you more energy, which makes you bigger, which makes you go faster. Next thing you know, you're sucked into the wormhole. That's how gravity works. And that's why people call being a wormhole when you go down a mental wormhole, it turns out that in that process, this is the insidious thing about any kind of wormhole, whether it's physical, like I'm saying, or if it's a mental wormhole. If any kind of wormhole, the longer you're in it, the more momentum it takes and work it takes you to get out of it. Because as you're getting bigger and more energetic, it's harder and harder to get yourself out of it as you wait to get out of it. It's like if I'm going through a mental wormhole and I wait 10 minutes, it's going to be harder to get out of it than it is right now. If I wait 20 minutes, it's going to be harder than that. Things spiral and they just go down the toilet really fast. And I don't know that's been used as a good metaphor for when people go mentally in a certain direction that's not good or healthy. That's the reason that's a good metaphor, because they really do exist. If wormholes didn't exist, if matter didn't bend space-time, then gravity wouldn't exist and we wouldn't be on this planet, and we'd just be floating around if we even existed in the first place. So physics and it's very fascinating, and the universe is fascinating. I'm whittling it down to you in layman's terms, so you don't have to do the math. Like I did that at Harvard College. I'm not, and I know it's like I could do that a little. Maybe I will in just a minute, but I'm whittling it down to just talk, which makes it easier to digest. But I'll give you one. There's one of Newton's laws. It should be Newton's for second. Maybe I don't know which Newton law it's called, but there's a Newton law called F equals ma. Force equals mass times acceleration. It's one of the most fundamental principles in classical physics. Classical as opposed to modern physics. Force equals mass times acceleration. It's kind of like the Ohm's law in electricity. V equals IR. Voltage equals current times resistance. Let me compare those, but first let me go with the force equals mass times acceleration. F equals ma. If the force goes up and the mass stays the same, you accelerate faster. Like if you're the same mass and you go fast and you put more force, i.e., more pedal on the gas, the more you accelerate. You go faster than you were when the pedal wasn't on the gas. And just like V equals IR in electronics, if the resistance stays the same and the voltage goes up, the current goes up. Because voltage is potential. It's energy that tends to make electrons move. And if the resistance is the same in any case, or except a constant, then as the voltage goes up, the current goes up. Hence V equals IR. Constant resistance, up voltage, up current. And then again with the F equals ma, if let's think of a good one here. Like the wormhole example, if I keep the acceleration constant and I add more force to it, I'll actually make that thing bigger. F equals ma. If A is a constant, if A stays the same, and F goes up, meaning you put more force on it, mass gets bigger. And V equals IR. If current is constant, then but the voltage goes up, that meant that the resistance went down, because you were able to get you were able to keep that same current, but it took more voltage to get it. Wait, voltage goes up, current, voltage, yes. You took more voltage to get that current to flow, therefore you must have had more resistance, which means R went up also. V equals IR. If current is the same in any case, and voltage goes up, that meant it takes more voltage to make that same current, which means resistance has also gone up. So there's just, science is really like a study of the universe, and when you get down to it, it's really no difference. At some level, it's no different than art or meditation, spirituality. If you do math long enough, you start to learn how to do music. if you do music long enough and you do math long enough, you learn how to meditate, and as kind of, I don't know, it helps your spirituality, I have a feeling. So anyway, I'm just talking. If there's anything else I want to say here, this whole universe is a mystery. Is a Goldilocks universe, because it doesn't have to be stable like it is, and have been stable for so long. They say the universe is about 14 billion years old. It begs the question, about the question of God again. And notice how I'm not saying this simply because it doesn't fit my agenda. I'm telling you like I see it. That's how my dad trained me. Call it like you see it, not like how you want to see it or how you want it to be. For us to be here, not only did the universe have to be Goldilocks, but within that Goldilocks, we had to be a Goldilocks Earth. So there's like at least 2 orders of Goldilocksness going on for us to exist. Now, what does that mean? I'm not an expert. Does that mean there has to be a God? Then if there, maybe so, maybe not. But if there is, does that mean the Bible has to be true? Maybe no, maybe so. I don't know. I'm just giving you guys food for thought. You think, do what you want with with it, but there's definitely order involved in our existence. In fact, there's so much order that we don't even understand. We can't even comprehend with our finite with our finite minds. We can't even comprehend how much genius and order is in our existence and the existence of our solar system and the existence of the universe. So, love you guys. Peace, love, and rock and roll.